Module 5.2, Floating Down the River, a solidify understanding task. So now let's take what we learned from our previous tasks and kind of make it a little bit stronger in our brains. So, Alonzo, Maria, and Sierra were floating in inner tubes down a river, enjoying their day. Alonzo noticed that sometimes the water level was higher in some places than in others. Maria noticed there were times they seemed to be moving faster than at other times. Sierra laughed and said, "Ha ha ha, math is everywhere." To learn more about the river, Alonzo and Maria collected data throughout the trip, which I'm sure you guys are all used to doing as you float down rivers. So, Alonzo created a table of values by measuring the depth of water every 10 minutes. Okay? So, we could say our input here is the time, so every 10 minutes, right? And then our depth in feet, so 4 feet here. I started out at 4 feet. At 10 minutes, we were at 6, at 28, 30, 10, 46, 5, and so on. Okay? So we've got a table there. So what we want to do here is use the data collected by Alonzo to interpret the key features of this relationship. Alright, key features. What does that mean? Well, if we're thinking about it, okay, it really comes down to these ideas. And we have this frame, features of functions, and there's a video that goes over it. But we're looking at these main things: domain and range, increasing, decreasing, x and y intercepts, maximums and minimums. We're probably also thinking about the rate of change or slope, okay, and that kind of stuff. Alright? So that's the idea as we look back here that we're going with. Okay, so now remember we've got the interval features, key features, and those would be the domain, okay, the range, where our function is increasing, and where is it decreasing. We also have our points, right? The points features. That would be like the x-intercept, the y-intercept, if any. The maximum or highest, the minimum or lowest point. Okay. Remember, with max and min, we're thinking about the y-axis, right? The output. X and y intercept, kind of the same idea there. Increasing and decreasing is also thinking about the y-axis, as is the range, and the domain is about the x-axis. Now, if we're thinking about average rate of change, or kind of that idea of the slope, remember, the slope is the y values over the x, the change in y over the change in x. Often they use this little triangle to mean, it's called the delta. It's a Greek symbol. It means change in y over change in x. We don't get that crazy. Alright, so let's take a look first at the domain. Domain is the x values, the input values. So, what is our domain? Well, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. All of those times. Now, there's two ways we could write this, being on the table. Okay, we could write just all those numbers down, saying this is the set of numbers that exist in the domain. And we would do this in the cases where the numbers in between don't count, which for this problem would probably be true. Okay. We would leave it like that because we're not measuring in between, the times in between, okay? But if we were measuring the time in between, and kind of the simpler, easier way to think about it would be domain is from 0 is the furthest left, 120 is the furthest right, okay? And we use those brackets when we're dealing with the intervals, okay? Points, we're going to use the parentheses. Okay, now the range would be looking at the y values, the depth, the output. Okay, so we have to find, now this is different, we don't just start left and go right. Technically, yes, on our range we could do the set notation and go 4, 6, 8, 10. We've already got 6. 5, we've already got 4, we've already got 5, 7, 12, 9, 6.5, and we already have 5. Because we don't need to repeat them. Probably want to put them in order. Okay, so that's one way we can do it. And typically with just a table, that's the way we should do it. However, I like to think more in terms of all the in-between. So the lowest point would have been 4. So we'd go 4. And then the highest point would be 12. So between 4 and 12 on the range, that's where we have that information. Okay? So, domain, remember all our possible x's. Range, all our possible y's. Now increasing and decreasing. So for this one, we have to compare. Okay? So, we go 4 to 6, that's increasing, right? To 8 is increasing, to 10 is increasing. Back down to 6 is decreasing. So in this section of the table, we're increasing. Okay? Then 6, we went down, 5, 4, we're decreasing. And then we jump up to 5, so we're increasing again. 7, 12, then back down to 9, 6.5, and 5. So we've got 2 sections of increasing, 2 sections of decreasing. Okay, so how do we write that? Well, we use the x value of our interval notation. So from this x value to this x value, we're increasing. So from 0 to 30, we're increasing. Then we jump and go from 70 to 90. And the way we do this is you put a little u in there and go 70 to 90. That's when we're increasing. So for decreasing, okay, down here, we start at 40, go to 60, then 100 to 120. So from 40 to 60, and then we jump 100 to 120. And I guess technically we should probably say, from starting at 90 we're really decreasing, right? And starting at 30 we're really decreasing. I probably should have wrote that instead, huh? Because that's when we start to decrease, 90 and 30. That looks better. Alright, so that's some of those key features. Domain, range, increasing, decreasing. So now let's take a look at the points version. So the x-intercept. So remember, when we're looking for an x-intercept, we want to know where is the y value 0. To have an x-intercept, we look for the y value of 0. Are any y values 0? Nope. So we don't have one. Okay? Because how could you tube in a depth of 0, right? Makes sense in our story problem. Okay, now our y-intercept. Where is the x value 0? Well, right here. So our point would be that connection right there. That 0, 4 is our y-intercept. Okay, 0, 4 is our y-intercept. Now the maximum and the minimum. So let's take a look at the y's. Where's the highest we go? 12. Where's the lowest we go? 4. So we have 2 minimums here, don't we? We could call this one, relative minimum if we wanted to, but we can have more than one minimum because they're the same. So our minimum would be the point 0, 4, our y-intercept, and then at 60 minutes and 4. Those would be our 2 minimums. Our maximum is 90 and 12, only one of these. So at 90 minutes, 12 feet of depth was our maximum depth. I know that seems like that should be a minimum, huh? And I guess if you were thinking about it that way, it depends on how you were thinking, you could flip-flop these two. Alright, now the last one, average rate of change. Okay, now these slopes change, so when we talk about average rate of change, you really have to have an interval. You have to say, what's our average rate of change from 30 to 70? Okay, and then we'd look at 10 to 5 and say our average rate of change was we went down 5, right? Would be like a negative 5. If we started from the beginning to the end, our average rate of change was only 1 foot. Okay? So it would be, 1 foot for every 120 minutes, or 5 feet for every 40 minutes. So with average rate of change, it really depends on the interval. What are you looking at? Unless you have just a straight line, then it's always the same. But if not, if your line goes up and down and up and down, you need to say from this point to this point, what's your average rate of change? What's that slope? Or from this point to this point, or from here to here. So it kind of depends on that. So we're not going to get into too much of that because, there's so many variables there. But there's the main ones right there. So there we go. All right, now looking at Maria and her data. Maria created a graph by collecting data on a GPS unit that told her the distance she had traveled over a period of time. Okay, so hers isn't the height of the water, the depth of the water. We still have time. Notice that the time was the same on both of these, okay, from 0 to 120, one in table form, one in graph form. But now instead of depth, she goes distance. So distance that they've traveled, which would make sense that 0, you'd start out as 0, right? Because you haven't went any distance. And at the end, that would be the furthest distance you went. Okay? So now, using the graph created by Maria, describe the key features of this relationship. So once again, we're using those same key features. And we also have that side of the frame that takes a look at domain and range, max, min, x and y intercepts, increasing and decreasing, from the point of view of the graph. Okay? So we're doing the same idea. Oops, too far. So we've got the intervals, key features. So that's, once again, domain, range, increasing, decreasing. For our points, we have the x-intercept, y-intercept, the maximum, and the minimum. And we also have that average rate of change, but just like before, it's going to depend on from where to where. Okay, so let's take a look first at domain and range. Okay, so the domain, where is our graph on this x-axis? Okay, so if we're simply walking here on the x-axis and saying, okay, there's still a graph above or below me, at what point do we stop? Right there. So the interval of our domain is from 0 to 120, which makes sense because it was the same amount of time. So 0 to 120. Now notice we didn't go through and write each time because distance, it's continuous. Whereas before, this was more discrete, so we shouldn't have written it like that. The graph here is continuous, so 0 to 120 works. Okay. Now the range is simply the same idea, but on the y-axis. So if I'm climbing up on the y-axis here, I start down here, climbing up, or if we were below, where can I reach out and could I, touch my graph? So we go clear up to right here, which is, what is that? So 1, 2, 3, 4, 5, so it's going by every 2,000, so 2,000, 4,000, 6,000, 8,000, 10, 12, 14, 16,000. So 16,000 feet. So from 0 feet to 16,000 feet is our range. Okay. Now, if we look at this graph, and remember when we think about increasing and decreasing, we always look left to right. Is my graph ever going down? Okay. Well, that would mean that we're getting closer. So if you're on a river and you start here, and the river goes and then, bends around, if you're talking about distance from your starting point, then yeah, it could come back down. But if we're talking about just distance, total distance, unless you go back up the river, your total distance is always going to be increasing. So notice with our graph from here up, it's kind of levels off right here, but because we're talking about distance, we know that it's not going to go back down, just kind of the way the graph was written. So decreasing it's never decreasing. Okay, mathematically the way you write it is you call it the empty set. Basically brackets or parentheses with nothing in, called an empty set. I like to use the word never or none. Now increasing, we increase from here to the end. So just like with our domain, it's from 0 to 120 for that. Okay, I probably shouldn't erase those numbers. Alright, now let's take a look at our points. Okay, so x-intercept, y-intercept. Where does it cross the x and y axis? Well, the only point is right here at 0, 0, the origin. So that's both of them. That is both our x-intercept and our y-intercept. That 0, 0 is the special one, right? Now, max and min. What's the lowest we're at? Well, where we started, right? Because we're talking about distance, so that's 0, 0 as well. What about our maximum? Well, the highest we go is right up here, so it would be 120 and then 16,000. So 120 to 16,000 is our maximum point. Okay, that point right there. Alright, now, average rate of change. That's the slope. Well, this isn't a straight line, so it doesn't have a constant slope. Its slope is changing. Okay, but we can figure that out. So, for example, we'd have to know time. So let's say from 50 minutes, well, let's actually use one that is easier to see. So we'll go from here, and let's say we went to here. Okay, what would be the slope from time in, so 30 minutes to 110 minutes? So that question would have to say, when you're talking about average rate of change, and it's not a linear equation, because the linear equation you just use a slope, we're essentially making this a linear equation and say the average rate of change is this. So we'd go up 2, 4, 6, 8, 10,000. That's our change in y. It's 10,000 feet. Then time, 10, 20, 30, 40, 50, 60, 70, 80. That's our change in x. So it would be 10,000 over 80. Simplify it, the zeros out. So 1,000 divided by 8, which we could cut it in half, actually in fourths, and that would be 250 over 2, which we can cut that in half, so it would be 125. So 125 feet every minute, essentially. That would be the average rate of change from 30 minutes to 110. But notice if we change our time, it's going to change that average rate of change. Okay. Another way you could have done it is just set change in y. Found out that this was 14,000. This was 4,000. Subtract them, you get 10,000. 110 minus 30, subtract it, you get 80. But there's kind of that average rate of change. But there we go. Alright, so it says Sierra looked at the data collected by her two friends and made several of her own observations. Explain why you either agree or disagree with each observation made. So let's take a look at these. So the depth of water increases and decreases throughout the 120 minutes of floating down the river. And if we looked back, yeah, it increases and decreases. So yeah, we should agree with that, right? That's true. Okay, the distance traveled is always increasing. Yeah, because we're traveling a distance away. The distance traveled is a function of time. Okay, is time our input? Yeah. So yes, according to the time, that determines our distance traveled. That's like the independent and dependent variable. So we should agree with that one as well. The distance traveled is greatest during the last 10 minutes of the trip than during any other 10-minute interval of time. So that would be kind of like looking at the slope here. So we're saying we're traveling the fastest, so if we're going faster, our distance should be steeper, right? We should be going more distance. So is this steeper than any other part here? Okay, that's what you're kind of trying to ask yourself in a 10-minute amount of time. So here's pretty slow. That's faster than that one. That one's faster than this one. Now it's kind of leveling it out. Okay, definitely not faster than this one right in here. This one isn't. So we're looking kind of that steepness isn't That one's pretty steep, definitely steeper than that one. But the last 10 minutes, no. It's either one of these two, I think, that would be faster. So we would disagree. Why? The explanation is in how we talk about it. Okay, the domain of the distance time graph is all real numbers. All real numbers would be every single number. Does our domain go that far? No, because we stopped traveling at 120 minutes. That's the farthest we go. All reals would go on till infinity. So we would disagree with that one. Disagree. The y-intercept of the depth of water over time function is 0, 0. No, for our depth, our y-intercept was 0, 4, right? If we go back to that, y-intercept 0, 4. So we would disagree with that one. The distance traveled increases and decreases over time. Okay, that's kind of the same way of saying it. This one, and we disagree with that. The water level is a function of time. Yeah, that is our independent. Time is our input, our independent. The water level is our dependent. So we agree with that one. The range of the distance time graph is from 0 to 15,000. Disagree, it was to 16,000. The domain of the depth of water with respect to time is from 0 to 120. Agree, right? That's, if we go back here, yep, 0 to 120. And they both were, right? They actually both were on that case. So we agree. The range of the depth of water over time is from 4 to 5. Okay, they're trying to be tricky here on this one. Remember, the range doesn't go from start to finish. So that's what they're trying to get you to think. It goes from the lowest points to the highest. So we would disagree with that one. The distance time graph has no maximum value. No, because we stopped traveling, so we disagree with that one. It does. We found it out. It was right there, right? Our maximum, right there. The depth of water reached a maximum at 30 minutes. So if we look at 30 minutes on our input here, okay, is that our maximum 10 feet? Nope, because our maximum was 12, so we would disagree with that one as well. So those key features help us understand what's going on, and that's kind of the whole point. It paints an easy picture of information so that we can then use that information from the graph for the table, which is the whole point of making a table or a graph, to have that information. Alright, so there we go. That one was a bit longer, but still good.